In this session, I am going to explain a topic final drives from the unit 1 of the course Farm Tractors and Construction Equipments, 5th semester Automobile Engineering. This topic covers introduction to final drive, types of final drive reductions such as single reduction final drive, double reduction final drive, double speed double reduction final drive, and then hub reduction axles. Again in that hub reduction axles, per gear reduction, epicyclic gear reduction. Final drives. As 5th semester students of automobile engineering, already you are familiar with these final drives. Anyhow, I am going to explain in brief these final drives. Final drive is the final gear reduction provided the drive axle or live axle. So in any vehicle transmission system, final drive is one of the device used at the drive axle. In the transmission system of vehicles, the gear reduction takes place at two instances, that is one at the gearbox and another one is at the final drives. What is the necessity of this gear reduction in the vehicle transmission? By providing gear reduction, we can increase the torque at the road wheels by decreasing the speed of road wheels, because to overcome road resistance or to propel the vehicle, more torque is necessary at the road wheels. So that torque is provided by these gear reductions. When the torque increases, tractive effort also increases. Tractive effort is the force available at the road wheels. Just I will give an example. Consider like that the gear ratio provided in gearbox is 2:1. The gear reduction provided at the final drive is 6:1. Then the overall gear ratio is 6 into 2, 12:1. Consider the engine speed is 6000 rpm. Then the wheel speed is 500 rpm. 6000 divided by 12. So the engine speed of 6000 rpm is reduced to 500 rpm at the wheel speed. So much reduction of speed increases the torque at the road wheels. Whatever the engine torque of the engine torque is multiplied 12 times at the road wheels, which provides necessary tractive effort to propel the vehicle. And another secondary function, this one is change the direction of rotation of drive through 90 degree. This final drive changes the direction of rotation through 90 degree in the case of front engine rear wheel drive. Here we are using hypoid gears as the set of gear for final drives. In case of front engine front wheel drive as well as in rear engine rear wheel drive, we need not to use these hypoid gears, because engines in those two cases, front engine front wheel drive, rear engine rear wheel drive, engine is placed horizontally, that means parallel to the drive axle. That's why there we can use per gears or a set of helical gears. We are using helical gears, so there no necessity of changing the drive through 90 degree. In some heavy commercial trucks, we are using two live axles at the rear. In that cases, we are using worm and wheel as the set of gears for final drive. Next, we shall go through types of final drive reductions. That is, first one is single reduction final drive, second one is double reduction final drive, third one is double speed double reduction final drive, fourth one is hub reduction axles. In this, you are using two types, per gear reduction, and second one is epicyclic gear reduction. Let me explain single reduction final drive. The single reduction final drive is used in all vehicles, cars, buses, trucks in common. This is a conventional type, and as the name itself implies, single reduction final drive gives the final gear reduction only in one instance. Here you can see that this is the drive pinion and this one is the ring gear. These two forms the final drive in single reduction final, because only one single reduction, only one set of gears provide the gear ratio. This drive pinion is very small. You can see that it may have 15 teeth or 16 teeth or like that, whereas this this crown wheel may have 80 teeth or 90 teeth like that. We can get up to 6:1 gear ratio, or even it is more than that. You see here 6:1 means if the propeller shaft rotates 6 times, this ring gear is rotating only one time. That means drive wheels are rotating only one rotation for every 6 rotations of the propeller shaft. Next, this crown wheel has a differential cage. In this differential cage, the two sun gears are provided, each on a half shaft. They are splinted to the respective half shaft. Left sun wheel is splinted to the left half shaft. Right sun wheel is splinted to the right half shaft. And in between that, the planetary pinions are mounted on the pins in the cage. Okay, this is also a set of gear. This final drive is also a set of gear. Differential cage is also a set of gear. Final drive provides gear ratio, but differential does not provide any gear ratio. Just it divides the torque that is given from the propeller shaft and ring gear. And the torque is equally divided to both the wheels by this differential cage while the vehicle is moving on a straight path. Let us consider vehicle is moving on straight path. The pinion is rotating in clockwise direction. Then this whole cage, including sun, pinion, everything, this whole unit is rotating as a single unit. The whole thing is rotating as a single unit, and both the wheels are rotating at same speed. Left side rear wheel and right side rear wheel both are rotating at same speed. The vehicle is moving on a straight path. So here there is no relative movement between the sun gears and pinion gears. Everything is rotating as a single unit. Let us consider the vehicle is taking a right turn. When the vehicle is taking right turn, the right side wheel offer more resistance to its movement rather than the left side wheel. Left side will offer less resistance, right side will offer more resistance because it is the inner wheel. The outer will offer less resistance. Then what happens? While this cage is revolving, then the planetary action of the pinions will takes place. These planetary pinions, they are rotating around the shaft, around the axial shaft, and at the same times they begins to spin around their pin, around the pin. That means they are moving around the shaft and they begins to spin around the pin. That means while they are spinning, they walk over the sun gear teeth, right side sun gear teeth, and now this pinion has two movements. One is around the shaft due to ring gear rotation, and another one is due to spinning of the planetary pinions. Then the left side wheel gets two moments by this planetary action. One moment is due to the rotation around the axle and another moment due to spinning of these pinions around their pins. Due to this, outer wheel gets more torque and inner wheel get less torque. That's why outer wheel rotate faster and inner wheel rotate slower. That's why vehicle can easily take turn. Like this, differential allows the vehicle to take turn with pure rolling of road wheels without any skid. So I hope you understood the final drive, differential, and what is single reduction final drive. So let us go through these calculations. Let Tp be the torque at the propeller shaft, Np be the speed of propeller shaft in RPM, Zp be the number of teeth on drive pinion, Zr be the number of teeth on crown wheel, Tw be the torque at the road wheel, Nw be the speed of the road wheels. Okay, here this pinion is driving gear, crown wheel is driven gear. So we know that gear ratio, how to calculate gear ratio, I suffix f equals teeth on driven gear divided by teeth on driving gear. That is also equal to speed of driving gear divided by speed of driven gear. Speed of driving gear means speed of propeller shaft. Speed of driven gear means speed of road wheels. The speed of road wheels is equal to speed of propeller shaft divided by gear ratio. Hence, the speed of the road wheels is decreased. At the same time, torque at the road wheel is equal to torque at the propeller shaft multiplied by the gear ratio. You can see here torque is enhanced, torque is multiplied, whereas the speed is decreased. You can easily understand by these simple calculations. Next, multiple choice questions. Why the pinion rotates faster in a meshed pair of gear wheels? Many options are given here. The pinion rotates faster because pinion is of less size or less diameter, whereas gear wheel has larger diameter. That means it has more number of teeth. Anyhow, their angular speed may be different, but the linear velocity of both the wheels same. That's why pinion rotates faster. Pinion rotates faster because of their linear velocity is same. That is the solution. What is the necessity of reduction gearing in tractors? Many options are given here. So in that, to increase tractive effort, to decrease tractive effort, to decrease power, to increase power, power does not increase, it remains constant, but we can increase the tractive effort by reduction gearing at the road wheels. So solution to increase tractive effort at the road wheels. Next, the crown and drive pinion forms final drive in case of hypoid gears or whatever hypoid gears. That is final drive. Next, the final drive increases the dash or the road wheels, torque, speed, velocity, acceleration. Naturally, it increases the torque at the road wheels. Next, the final drive decreases what? Decreases the dash of the road wheels, torque, speed, skid, jerk, speed of the road wheels. Thank you.